All right, so we are going to be talking about solving multi-step equations today. So just a couple quick reminders. Okay, we are using inverse operations, which basically is saying that two operations that undo each other. Okay, addition undoes subtraction, subtraction undoes addition, multiplication undoes division, and division undoes multiplication. Okay, and also remember, we only can add or subtract things that are like terms. Okay, like terms again are things whose variable are the exact same. Okay, examples of that, 2x, 3x, so I can add or subtract those together. 3 and 7, 3x squared, and x squared. Okay, those are all things that are like terms. All right, so let's actually look at some examples of working out solving equations. So remember, our main thing when we are solving equations is we want to get the variable by itself. So right now I have two x's. Okay, notice x and x, the exact same variable with the exact same exponent. So these two are like terms. I can add these two together. Okay, I'm going to take the sign in front of the 6x as well. So I get 9x minus 6x, which gives me 3x. Plus 15, which is equal to our negative 12. All right, so now I can use my inverse operations and get x by itself. Okay, I want to get x by itself. Now, I've got the 3 next to the x, and I've got 15. Okay, I am going to undo the 15 first and use its inverse operation, which would be minus 15. Okay, we always undo anything that is adding or subtracting first before we move on to multiply and divide. All right, so 15 plus a negative 15, or 15 minus 15 is 0, so those cancel out, and I am left with 3x. Let me write that a little better. 3x is equal to a negative 27. All right. So now I can get the x by itself. Okay, 3 is doing what operation? It's multiplying. Okay, so we undo multiplication by division. So x is going to equal a negative 9. And there is our solution. Okay, x has to be negative 9. All right, so let's look at another example. Here I go again, bumping the camera. All right, so again, need to combine my like terms first. So I've got negative 2x and negative 10x. Okay, when I combine those together, I get 18 is equal to negative 12x plus 12. All right, so now I've got a single variable. I can solve for that variable. All right, so always undo addition, subtraction first. So 12 is adding, so we are going to subtract. Okay, 18 minus 12 is a positive 6. 12 minus 12 is 0, leaving me with a negative 12x. All right, from there, my 12 is multiplying to x. So, to isolate x, or get x by itself, I need to divide by 12. Or divide by a negative 12, I should say. Okay, negative 12 divided by negative 12 is 1, which is what we want. We want it to become, when we're multiplying and dividing, we want it to become 1. Okay, 6 divided by a negative 12 is going to be a negative 1/2. Okay, 6 and 12 are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2, giving us the negative 1/2. So my solution is x is equal to negative 1/2. Not too bad. So remember, we are working towards isolating the variable, getting it by itself. All right, so let's look at a couple with parentheses. Now, I have two ways we can work this one out, and they both work well. Okay, you can either do the distributive property, or you can divide first. Both work. I'm going to start by working the distributive property. Okay, and remember, with the distributive property, all that means is I'm going to take the number outside the parentheses and multiply to what is inside the parentheses. So I'm going to take 2 times x plus 2 times 5. Okay, and that's still equal to our 8. Now, you do not necessarily have to write this step. I'm doing it to show you. Okay, so 2 times x is just 2x plus 2 times 5, which is 10. Okay, again, that step I wrote right there could have been skipped. I could have just done it automatically. All right, so now I've got something I can work with. So I'm going to use the inverse operations and subtract 10 from both sides, leaving me with 2x is equal to, okay, 8 minus 10, which is a negative 2. Then, okay, 2 is multiplying to x, so divide by 2. Okay, those two cancel each other out, become 1, and we've got x is equal to negative 2 divided by 2, which is a negative 1. All right, I am going to show you the other method. Okay, so instead of distributing, okay, because the 2 is multiplying to the x plus 5, I can divide both sides by 2. Okay, those 2's will cancel out, and I am left with x plus 5 is equal to 4. So from here, I've got x plus 5. I need to use my inverse operations to isolate x. So I can subtract 5 from both sides, giving me x is equal to negative 1. Again, both methods work. Both methods are correct. It does not matter which one you use. Okay. All right. Last example for this video. All right, I've got 3/2 times x plus 6 is equal to 15. Okay, I can use the same methods I did in the last example to solve for this one. All right, so I'm going to start with the distributive property first. So I'm going to take 3/2 times x and 3/2 times 6. Again, I'm writing this step so everybody sees what I'm doing. Okay, so 3/2 times x is 3/2 x plus 3/2 times 6. Okay, 3 times 6 is 18. 18 divided by 2 is 9. And we're still equal to that 15. Alright, so I'm going to do my inverse operation to both sides, starting with addition, subtraction, and I'm going to minus 9 from both sides. So we still have our 3/2 x. 9 minus 9 is 0. Bring down our equal sign. 15 minus 9 is 6. Alright, so now, okay, 3/2 is multiplying to x. But if I were to divide by a fraction, that just doesn't look nice. So, in mathematics, we know that if we have to divide by a fraction, we can also multiply by its inverse, or its reciprocal. So, reciprocal, guys, remember, is if I take a fraction, such as 3/2, okay, I can flip that fraction, and that's its reciprocal. Alright. So, I'm going to take both sides and multiply by the reciprocal. When I multiply by this reciprocal, it actually gives me, when I multiply the reciprocal to itself, it gives me its 1. Alright, so that cancels out. And I'm left with x on this side. 6 times 2 is 12. Divided by 3 is 4. Okay. So I could do a similar method to dividing over here. I can take and multiply by its reciprocal to both sides. Okay, canceling out my fraction there, leaving me with x plus 6 equal to, okay, 15 times 2 is 30. Divided by 3 is 10. Can subtract my 6 from both sides by doing the inverse. And x is equal to 4. Again, two methods, both work. Alright, that's where I'm going to stop this video today.